Now we want to start working through a couple of examples of an ellipse. A couple things I want to just clarify as we go through this. A is what we call the distance from the vertices to the center, and then C is the distance from the foci to the center. One of the things you'll fall into the trap of saying is that your foci are foci are your C value and your vertices are your A value. That's only the case when our ellipse is centered at 0, 0. When we're not centered at 0, 0, we've got to do some math. So just realize whenever we're talking about A, it's the distance from the center to the vertices. And it looks a lot when we start off that A are the vertices, but that's only because we're centered at 0, 0. The same thing with the foci and the C value. So just make a note that the A value and C value are distances. It's not necessarily a coordinate plane, or it is a coordinate point, but it's represented from the distance from the center. So if we've got x and y's of the first degree, you will need to complete the square to get your ellipse in standard form if it's not in standard form quite yet. So looking at the first example, find the center, vertices, foci, and eccentricity of the ellipse. Draw a quick sketch of it, and then how would we enter it into our graphing calculator? And specifically graphing calculator, we're doing rectangular coordinates right now. Rectangular coordinates is functional mode on your calculator. We'll get into the polar and parametric forms a little later in the chapter. So I'm given the equation 9x squared plus 4y squared is equal to 36. Now if you remember, we said that standard form of an ellipse is equal to 1. So the first thing we need to do is divide everything by 36, so we're equal to 1. So then that'll simplify down to x squared over 4 plus y squared over 9 is equal to 1. Now that I'm in standard form, I can ask myself, is this going to be a horizontally stretched ellipse, or is it going to be a vertically stretched ellipse? And the way we determine is we look at which part has the larger denominator. If the x part has the larger denominator, that means we're going to be stretched in the x direction more. If we have a larger number in the y portion, that means we're going to be stretched vertically more. So right here, x squared over 4 plus y squared over 9 is equal to 1. That means we are going to be stretched more in the y direction. Now, one other thing that I probably want to add on here somewhere is our standard form for an ellipse. And the standard form is going to be one of two things. X squared over a squared plus y squared over b squared is equal to 1. This right here is going to be your horizontal ellipse. If I have x squared over b squared plus y squared over a squared is equal to 1, that is going to be the vertical ellipse. And the only thing that's different there are the b's and a's. Whenever you have an A, that's going to be referring to your major axis, or the longer piece. The B refers to the minor axis, or the shorter piece. So if we have something that's stretched horizontally, a horizontal ellipse, the major axis is underneath the x piece, which means it's going to be longer in the x direction than in the y direction. Over here, the vertical ellipse means that we are going to be longer in the y direction. So the A value, which means the major axis or the longer direction, is underneath the y portion of the fraction. So when I look at this piece right here, we know that this 9 is tied to the major axis, this 4 is tied to the minor axis, and since the major axis is underneath the y piece, we're going to have a vertical ellipse. Since our standard form has an a squared in the denominator, that means this value is a squared. So the first thing I'm going to do is I'm going to take the square root of each of these denominators. And this right here is going to give me my a value, and that's going to give me my b value. Remember from what we said up here, A is the distance from the vertices to the center. So this A value with 3 units is going to tell us our distance from the center to the vertices. So here I've got no horizontal or vertical shift, so my center's at 0, 0. And I'm going to go 3 units up. I'm going to mark that as a vertice. I'm going to go 3 units down. And that's going to be a vertice. That's also going to give me my major axis, since that'll be the longer piece. Here, my minor axis, my B value's got a value of 2. So we'll go out 2 units to the left and 2 units to the right. And then we'll draw in the very quick sketch of our ellipse right there. So we want to find the center. We know the center is going to be 0, 0. Vertices, we've got one at 0, 3 and 0, negative 3. Next thing we want are the foci. And the formula for the foci is c squared equals a squared minus b squared. And I know up here a squared is 9 and b squared is 4. So c squared is 9 minus 4. So c squared is 5. So c is plus and minus square root of 5. What that tells me is one foci is square root of 5 units up and one is square root of 5 units down. So square root of 5 is a little more than 2. So my foci is going to be somewhere right there and then somewhere right down there. A little more than 2 units each way. So that ordered pair is 0 square root of 5 and 0 negative square root of 5. Eccentricity of the ellipse. Eccentricity is c divided by a. My c value we have here is square root of 5. The a value is going to be 3. Plug that into our calculator. That's about 0.745. And then the last piece is, how would you enter it into your graphing calculator? For that, we want to go back to our original. 9x squared plus 4y squared is equal to 36. And since we want to solve this in rectangular coordinates, we're going to solve for y here. So 4y squared is equal to 36 minus 9x squared. Divide both sides by 4. So 9 minus 9/4 x squared. And then take the square root to both sides. So y is equal to plus or minus the square root of 9 minus 9/4 x squared. If you wanted to leave that as 36 minus 9x squared all over 4, that works as well. My advice to you is to try and not simplify. Since we're just plugging this into our calculator, I really don't care if I completely simplify because the calculator will do it for me. And the reason I recommend not trying to simplify more is chances are you're going to make an algebra mistake. Right here, if I see students try and simplify, they might want to break this into 2 separate pieces and say this is 3, square root of 9 is 3. This would then be 3 halves x. And we know 3 minus 3 halves x is a straight line. That's definitely not an ellipse, and we can't do that mathematically. We can't just split something that's underneath the square root into 2 separate square roots when it's being subtracted. So my advice is just to leave that as is and plug it into your calculator.